Hello, everyone. Welcome to another episode of Scaling with Demi. This is episode 7. In this episode, I'll be talking about asking for forgiveness versus looking before you leap. And I know this kind of has some motivational vibe to it. I promise it's purely software. I'm not. I am not a motivational speaker, but we'll be looking at it within the context of software, right? Some architectural decisions that goes into building software, and there are two programming languages that I'll be using as kind of to compare these two mental models, right? These two phenomena, right? And for asking for forgiveness, we'll be looking at Java, and for looking before you leap, we'll be looking at Python. Before I go too deep into it, my last episode where I talked about idempotency, I had two questions from which I'll be addressing right now. To the best of my knowledge, if you have any questions or a different perspective, or if you completely disagree with everything I say, just put it in the YouTube comments there, and I'm definitely going to share my perspective or agree with you or disagree with you. Don't also forget to follow me on Twitter. I'm trying to work on my online presence. So just, you can tweet at me, ask me some questions. I'll try as much as possible to respond as fast as I can. So question 1 from Tobiloba Owolabi at 1454. If you have a process where each step causes a trigger for the next step, and one of the steps in this chain fails, we want to be able to restart from that step later in the future, but that would mean that the step needs to have all the data necessary to pick up from that point of failure. Is this good or bad for the system, or am I even correct? And yeah, this is a very interesting question, right? And it is very correct, right? That every step has to, if you can see it in the previous video, in the idempotency video, the demonstration I gave, every step has to have the data, all the knowledge required to run its own process, right? And typically you're going to be using typically you're going to be using a queue for this. I mean, if you're using Node.js, you can use Boolean queue. And when you pass in the data into the queue, if there is a failure, you can easily retry it or restart it because that data remains in the queue. You can set a time to delete the data. That's a different discussion. But yes, each process would have memory or all the data required to run its process. So you are very correct on this. And that is not a bad, that's a good thing. One thing to note though, you don't want to be passing in complex data structures in between processes or in between methods, right? In between each of these processes. So if you are processing a PDF, you don't want to pass in the PDF file or the PDF string or base64 string from one process to another, but rather you want to pass in a reference to the PDF so that that new process can pick it up from where it stops. This prevents you from loading large data in memory. You just passing references, passing. One way I remember we will be on Rails. One very good way to think about it was to pass in primitives, right? Just strings, integers. Don't try to pass in objects, JSON. Just stick with the primitives, and that would work. Thank you for that. Another question from Damilola Fakorede. Hey, thank you very much for this. I actually learned quite a lot. I should not do that. But I have a question. What if I have about 4 flows? User sign up, create CRM, update CRM, and send bonus. If the sign up works well and I inform users about and based on the first step, where they call themselves, the others fail, am I going to have a cron for each of the other process? Cron for create CRM, update CRM, and each cron. I will check if the process has been completed. And yes, and I'll check if the process has been completed based on the reference on in database. E.g., if the cron for update CRM runs, I will check if it has completed in database, and if it has not completed, I will move on to the next one, which is send bonus. But won't there be an issue if send bonus cron runs after 2 minutes? You are really thinking of this. Yeah, so this is correct. And the way to think about it is, usually for most systems, it's not really a problem if there is a delay in the time it is actually run. Now, if you are working on a system that a delay is, it has to be run almost immediately, then you're going to be redesigning it a little bit differently. But things like creating the CRM, you really don't care when that runs. You just want to update the CRM with the correct records, the correct created art field for that user. The send bonus, it affects user experience a little bit, but you should not be having downtime in the first place, right? The API should be working. So these are actually edge cases that you're catering for. So even if the crons are running, if it's running after 2 minutes, it shouldn't be much of a problem, provided the end result still ends up happening. And note, as stated earlier in the conversation, these are all asynchronous systems, right? For synchronous system whereby time is critical, you want to think about this a little bit more differently. You can't really use crons. You'll be thinking really of using retriables in the synchronous flow. I've worked with systems like that before. We could talk more about it. You could just chat me up on Twitter or ask a follow-up question, talk more about it. But yeah, you want to be thinking of using more synchronous retriables as opposed to depending on asynchronous crumbs to picking up the flow. So it shouldn't be much of a problem if the user receives this bonus 2 minutes later, provided this is effectively communicated. This is more of a product management problem or a product design problem. Right? Provided it's communicated appropriately to the user, they'll be fine. And that's it. If you have any further question on any of the videos or the content, I'm very glad to help out with this. Back to the show. Welcome once again to this episode. I am talking about asking for forgiveness versus looking before you leap. And like I earlier stated in the disclaimer, this is not a motivational talk. This is actually software systems. Talking about two popular software systems that kind of like took some opinions, some extent around this, which is Python for looking before you leap and asking for forgiveness, which Java took. I'll kind of like be explaining the pros and cons. Giving my perspective on this, these are all opinionated systems, so I would really love to see your angle on this, what you would prefer or how you think around this in products you're working on. So let's look at the first flow, right? Looking before you leap, right? And this comes from, I mean, you would all be familiar with this, right? This is really applicable when you're developing systems. So I'll use a banking application as an example. I tend to use fintech a lot because a lot of my background comes from fintech. So I'll use a banking application for an example in which I want to make a transfer. I want to make a withdrawal, actually. I want to make a withdrawal from my account. Right? So I go to the ATM and I'm supposed to make a withdrawal. And using the look before you leap approach, right? I mean, this is a code for something like this, yeah? You would see that I would first make an if statement, which is if balance is below X amount, or if balance is above amount to be withdrawn, call withdraw amount. So you're probably doing a check. If balance is less than amount to be withdrawn, then you don't allow the user withdraw, else allow the user withdraw, right? Which is the concept of looking before you leap. You look, does this user have account, the right amount to the account? And if the user doesn't have the amount, you don't allow the user to withdraw. You look before you leap, and if the user has the right amount, you allow the user to withdraw. And this is great. This is how many of us even develop, like when we are learning how to build software. This is how we go about developing software, right? And this works. But for some systems, right, there might be some cons attached to this. Like this is simple, it works. You throw errors and immediately you discover the truthy conditional statement immediately, and you throw an error. Like it's perfect. But there are some gotchas that could come from this, right? For example, you could get to a situation whereby you have a lot of if statements, right? So you kind of like have this loop of if this. Your code starts becoming very messy and difficult to read or difficult to track. And there are some ways to address, kind of like solve that problem using things like early returns. But the problem with using early returns is you create a situation whereby you have multiple returns within the methods, which creates another problem, another opinionated system. Some people believe a method should only have one return to force consistency of data type and the amount of data returned. Now, if you're using a typed language, that is not really a problem because your TypeScript or Java will enforce the returns, right, value. But if you're not using a typed language, it's very easy for you to start returning number here, returning void here, returning an actual data here, because you have multiple returns. I will talk about early returns in another video. But basically, looking before you leap, you could end up having this long if statement or multiple if statements within the method, which can make things very difficult to track or very difficult to modify or edit, right? Because you want to check all the conditions before you actually call the method. If user can withdraw, if there's connection, if before you withdraw. Another problem and this one, I think this one is a little bit more interesting than the if, because the if is kind of like a syntactical problem, like your code start looking messy. So because we want to look before we leap, we could potentially enter a situation in which the parent method, the caller, the looker in this case, right, has to be aware of the implementation details of the method it is calling, which could cause a lot of repetition, but also reduces the separation of concerns. So there's this method that says I'm going to call I want to withdraw money from this user account. The name of the method is process some transactions. And that method now has to know how to check if the user has money in his account, right? Has to be able to also check. There may be some other implementation details that has to do with withdrawing amounts, some that could potentially throw an error. So this project method now has to be able to check for each of those, which it's not really his business, right? It's just supposed to call the withdraw amount, and that withdraw amount handles every other thing for you, right? But now it has to know all the implementation, all the variables, not all, but a lot of the variables that exist within the method that is being called. So that could mean you are checking here, you're checking like 10 million places just to do one action. So which the other approach now come, which is just ask for forgiveness, right? I mean, I'll still explain other cons of this first approach, but for the ask for forgiveness approach, what you're really doing is saying, oh, I'm just going to call the withdraw method. Withdraw money for this user, and when an error is thrown that like you don't have the correct amount, like look at this on my screen, this example. Withdraw money from this user, and maybe there's an insufficient fund exception. And an exception in programming is like an unplanned event, such as an invalid input, something that is not part of your happy flow or the expected flow, right? So we try an exception. In this case, I mean, insufficient balance is not necessarily an exception in this case because we can preempt it, but still, just for the purpose of this, let's call it an exception. So we try an exception, insufficient balance exception. And after throwing that exception, we catch it and we can respond to it adequately. So I'm not looking before I leap. I'm just saying, oh, withdraw money from this account, and so many potential exceptions could be thrown, so many potential errors could be thrown. And I just keep catching each of those errors. Like you can see how it's done here on my screen. I just keep catching each of those errors. And after catching them, I act on that, right? So I don't really need to know the implementation details for how the method itself checks if the balance is okay, checks if there is network connectivity, checks all the variables in between. I just know that I'm calling this method. The methods have declared some interfaces for me, the argument I'm going to pass in, the expected return value, and the potential errors that can be thrown. And I just work with that. But yeah, that works. But then this creates a different problem if you're using this approach. I mean, like I said, there are pros and cons to this approach, right? If you're doing this approach, you have a situation in which you could get to a point in which you're using exceptions to control flow. Now, exceptions are supposed to be unplanned events. So something like an insufficient balance. I mean, many of us are broke, right? So insufficient balance is not necessarily an unplanned event. It's just an event that I should plan for. Like I'm broke. But choosing it as an unplanned event is using exception to control the flow of the system, which could cause a lot of side effects. For example, if your system has side effects, so before I try to withdraw amount, say I initiate another transaction, right? Then that withdrawal amount now throws an error. So your system has a side effect in which that withdrawal amount does something else before actually first making that withdrawal amount that now throws the error. You have a situation with just side effect would have happened. So let me take a very good example, right? So if I want to, so if there are side effects, so if there are like side effects, so for example, I want to withdraw amount, and that withdrawing amount is supposed to send and trigger an SMS to be sent that, oh, someone is about to withdraw an amount, use this OTP, right, to confirm that, something like that, right, to confirm that this user can withdraw this amount. That OTP would have been sent, got in, then I type in, then it tries to withdraw the amount, then it sees the sufficient balance. So that OTP being sent to the side effect. Now, this is an harmless side effect, right? But there's some instances in which those side effects are not harmless, and you'll be in a situation in which you've triggered those. So you have to find a way to now clean up those side effects because the amount was actually not withdrawn or the flow was terminated. Now, if you've checked earlier on, you would not have bothered executing any of these side effects. So this is a situation in which the looking before you leap is beneficial. Kind of like just jumping between the two of them. So to give a quick rundown of it, you don't get to use exceptions to control the flow, which to many people is very important, right? Especially because there are some, I'm not sure if it's C++, you can just share your perspective in the comment, but there's a programming language that did not really optimize the exception flow because exceptions are exceptions. Like they're not supposed to really control the flow of data or flow of information in your projects, right? That was not what they're designed for initially, right? So, and they might use more memory, they might not be as performant as you want. Maybe not very much in 2022. Most guys have optimized their system. Most programming languages are optimized all around. But with looking for a leap, you are not really using exceptions to control flow. That's one. Number two, side effects. You don't, if you, I mean, you have looked right before you leapt. So you're not triggering any side effects that could come with trying to leap. In a more practical example in real life, not a more non-practical example, which is I jump from a plane, then I realize my parachute does not work. I mean, I'm already jumping, so I'm kind of like screwed already. But with this one, you've looked, you've checked, no side effect happens if the parachute does not work, right? You've looked to check if the user does not have enough money in the account, if there's no network connectivity, if all these variables don't work, the transactions never even get, the flow of transactions never even get triggered in the first place. So you are safe from that. So you don't have to like clean up, you don't have to like implement a cleanup mechanism or worry about those. And so, but some of the concerns, some of the con with looking for a leap now becomes separation of concerns, right? The method that is calling the withdraw method now has to also know how to navigate around, how to check around some of the implementation of the withdraw method itself. Some of the things that the withdraw method is dependent on, the person calling now has to be aware of it and check it on its own, which now means that a lot of business logic is spilling out to external methods and external methods, right? Instead of a class or a library method, just undo its own business and throw a certain error, expose a certain interface. So that's one problem with using the look before you leap approach. There tend to be spillover of business logics, right, across different methods. So you might say, oh, we can create a class and object that contains the behavior, so we don't need to expose the data from the child method to the parent method using the object-oriented approach. And yes, that is true in some ways, but we'll talk about that in another video. Another potential problem with looking for a leap is race condition. And race condition happens when you are trying to do one thing and within a very tiny millisecond, right, another system tried to do a similar thing. And I mean, it's one of the very popular bugs of fintech systems. So let me give an example. I tried to withdraw money from my account. I have 100 naira in my account. Yeah, I'm broke. 100 naira in my account. I tried to withdraw 17 naira from my account. Then they look in before the leap system checks and says, oh, you have 100 naira, so you should be able to withdraw 17 naira. But before it withdraws the amount, another system checks just within the space of milliseconds and says, oh, you have 100 naira. You should be able to withdraw 17 naira. Now, these two guys have checked. So this guy withdraws the 17 naira. I'm supposed to be left with 13 naira. This guy does not see the 13 naira because he has already checked and saw 100 naira within that very short period of time. And these are computers, right? They execute there is a time between execution. So it sees it and also debits me. And now I have two transactions. And there was this, was it Bitcoin or one crypto guy that used this race condition to make like millions of dollars across some crypto systems by automating some of these things. I mean, it's maybe not best, but one way that a lot of fintech gets hacked by this race condition. But because you are depending on looking before you leap, race condition, you are susceptible to race conditions. And so that's another con of it. But for the asking for forgiveness, you are more like, oh, I'll just call you. I'll assume you throw error when there's an error. And since you've told me the errors you'll be throwing, I would handle the error in my case. Like, don't forget, say the method here for an example of an asking for forgiveness system. It's actually not called asking for forgiveness. It's called coupled looking with leaping. But I just think asking for forgiveness sounds a lot better than coupled looking with leaping. So in this case, race condition is potentially avoided because when I try to withdraw, if there's an insufficient balance, that method throws an error, right? And after the error is thrown, I can respond to it. So if two guys try to withdraw at the same time, one of them will shall work. And once that one has executed, the other one will say, bro, insufficient balance, you can't withdraw. I mean, there might still be some ways race condition can still slip in, but like you've optimized it to some extent. Another benefit of the asking for forgiveness approach is you don't really have to know what is going on in between. So when I call my doctor, for example, that, I have malaria, I have a headache or something, and can you diagnose me? I don't really have to know what is going on with his life before I call him. I don't have to check, is his wife angry at him, or is his husband angry at her, or is he having a bad day? It's not my business, bro. Just, can you prescribe the medicine for me, right? Separation of concerns is a lot easier. Another benefit of the asking for forgiveness would be, like I said, reduce likelihood of race condition, and also libraries can just expose arguments, error messages, and return value, right? The problem with the one pro of ways of looking for a leap is you don't get to run side effects. One of the cons of looking for a leap is there might be side effects that have been run before an actual error is thrown. I hope I've been able to just give a rough overview of some of these concepts. Many of this is opinionated. Let me know in the comments which you prefer, which approach you think is better for you. Many of this is opinionated. I'll also leave links in the description that would give you more context on this. I have to reach some of these links to see other people's perspective on this before sharing this. One thing you might not really want, in more practically, things are not perfect. You could never really have a black and white system, right? So maybe a combination of both. You check for some of the more obvious conditions. If you're going to withdraw money, right, you have to have the money in your account. So that's an obvious condition. So you check for those, you look before you leap for those. And for less obvious condition, you depend on an error being thrown by the system and you catch those errors. So more practically, you probably want to use a combination of both, but still, let me know what you think. Thank you for watching this video. Don't forget to subscribe and turn on notification. If you have any question, leave it in the description and I'll try my best to answer as best as I can. If you have a different perspective or a different opinion, I'll be very happy to see it. Follow me on Twitter at Demi. Bye.